Progressive web applications, very popular and useful technology. What if I told you you could check a box, use your .NET language of choice, and publish a Blazor web app as a progressive web app? Watch this episode of On.NET. Hello and welcome to another episode of On.NET. I'm your host, Jeremy Lickness, and today we're talking about two exciting web topics, at least for me. First is Blazor. Second is progressive web applications. It's the cool new thing. Well, it's not that new, but it's a great feature. And we're going to dive in. I have with me Dan Roth. Dan, welcome.
Hi, everyone. Thank you.
Dan, tell us a little bit about what you do at Microsoft.
Well, I'm a program manager, and I work on the ASP.NET team. Specifically, I've been working on Blazor as a way to enable full-stack web development with .NET.
So Blazor is something that has been around for a while. I know when it was first announced, I got a little bit excited, and then I dug into it and started building a project and got very excited. But it allows us to build single-page apps with C#. And one of the things that people love about single-page apps is the ability to do a progressive web application. Can you explain what a PWA is and why anyone would even want to have one?
Yeah, sure. I can do that. I have a slide or two actually to help out with that. Why don't we go to the slide real quick? There it is. So just a quick overview of what progressive web apps are. I mean, progressive web apps, or PWAs, are just normal web apps, but they leverage a few additional modern web standards to give the app a more native app-like feel. For example, the app can be installed on your platform of choice, so that if you're using like a Windows machine, you can launch the app from your start menu and give it an icon and give it a sort of a native Chrome or shell around the application, so it feels like a native app. If you're on a phone, you can launch it from your home screen, like pin it to your home screen. They can work offline, so they don't have to have a network connection after they've done their first load. They can cache the assets needed to run the app and then function afterwards offline. They can do push notifications, so that you can send notifications to your user even when the application isn't running. And these are all done with just standards and open web standards. It's still a web app, but it gives you that more native app-like feel.
So I've worked with PWAs. I have a blog that I turned into a PWA. And to do that, I worked with those open web standards and had to create a service worker with JavaScript. And there were about 5 million examples on the web, and trying to figure out what things actually did. It took a lot of effort. I finally got it working, but it was a bit of work to get there. How does that experience work with Blazor?
Well, we try to make it easy for you in Blazor to get you set up as a PWA. There are a few things you need to do with a Blazor web application to turn it into a PWA. And actually, if I could go back to slides real quick, I'll go over a couple of those things and how we help you with that. Let me hop back here. Yeah, okay. So first of all, to make the app installable, you really need three things in the application. You're first of all going to need a web manifest, which is just a JSON file that describes the app. It adds some metadata to the app, what its name is, how it should look when it's running, like should it be full screen, should it be in its own window, what color do you want on the Chrome, what icons do you want to use when it's pinned to your start screen or to your phone's home screen. The app needs to be run under HTTPS. And then, like you said, you're going to need a service worker with at least a functional fetch handler so that browsers will recognize that this is an installable app. And there's lots of ways to customize this experience. You can do fancy things like have an in-app installation experience. But those are the basics. If you haven't heard of service workers before, if you're not familiar with what those are, a service worker is just a chunk of JavaScript. It's a script that the browser downloads with your app, and your app registers, and it runs in the background separate from your app. And service workers can do a bunch of things, but in PWAs, one of the key pieces of functionality they provide is they can act sort of as like a network proxy, allowing you to control how requests are handled. For example, you can intercept requests, and instead of going to the server, you can provide the requested file from a cache, and that can enable things like offline support. To use service workers, you do need to run under HTTPS. Fortunately, ASP.NET Core and Blazor will handle that for you, and they get registered on page load. So I'll show you real quick what that looks like in Blazor. By the way, if you haven't gotten started with Blazor yet, go to blazor.net. That's the magic URL. And just click on the Get Started button, install the .NET Core SDK, and you should be able to get it up and running, no problem. I've already done all that. So I'm going to go ahead and create a new Blazor app. I'm just in Visual Studio 2019. Let's click Next. I'm going to call this Blazor PWA. Seems like a good name. And then for all these options, I'm going to select Blazor WebAssembly app for my PWA. That's the one that has this additional PWA option down at the bottom, which I've already checked previously, so it's checked for me. I'm also going to check this ASP.NET Core hosted option. This option will pair my Blazor WebAssembly app with an ASP.NET Core backend. And that's not required to build a PWA, but it's convenient for some testing that I'm going to want to do. Blazor lights up certain PWA-related behaviors only when the app is published. It's a little easier to run the published app if it's ASP.NET Core hosted locally on my machine. Alternatively, you could publish it some way, like somewhere like to an Azure Static Web App and just run it there. So let's go ahead and create that, and we'll see what we get for our PWA. So we have our standard 3 projects in our solution. We've got our backend ASP.NET Core server project, the Blazor WebAssembly client project, and then that shared class library. I'm going to go ahead and run this locally on my machine so we can see the application and see what did checking the PWA checkbox do for me. Well, if we look at this app, it looks pretty standard Blazor application. We've got our lovely purple gradient. Let me resize this a little bit. We've got the counter, we've got the fetch data page, all that's working, no JavaScript required. The thing that's different is that Edge is detecting up here that this app is installable. I've got this little plus sign, and I can say I would like to install this Blazor WebAssembly app on my machine. And now I can close the browser, and it looks like a native application. It's got like a nice, pretty shell that matches the color of my application. All the same functionality still works. If I go to my start menu, we can see that this app now shows up in my start menu. I can launch it from there. Now I've got 2 instances. So it looks and feels more like a native app. I was able to install it on my machine. How did that happen? Like what made that so? If we go look at the Blazor WebAssembly project, there are a couple of additional files that we added to this project for you by checking that PWA option. The first is a web manifest, this manifest.json file. And you can see it's just a chunk of JSON. It has the name of the app. How do we want it to be displayed? Like, should it have a standalone window or should it be full screen? Some colors that we want to use for the Chrome, and then icons that we want to use when the app is pinned or showing up in its own Chrome. So that's the first thing. The second thing is we set up a service worker. So here's the default service worker file, which looks pretty bare bones. Like it doesn't have much in it at all. That's because this is the service worker that you'll use during development. This service worker does very little so that you don't have any caching issues while you're trying to iterate on your app during development. But when you publish it, that service worker will be swapped out for this one, which has got a little bit more going on. This is one of those recipes, Jeremy, that you were talking about. This service worker is handling caching of the app assets and clearing out old cached assets so that this app can run offline. And we'll look at offline scenarios in just a second. These files get wired up into the app in the index.html file. So here's where the web manifest file is linked in the head of the HTML page. And then down below, you can see the service worker is being registered in the script tag. There's a little bit of MS Build magic as well to do that swapping of the service workers when the app is published. So by default, we're going to use service worker JS, but when we publish, we'll use that published JS file. So that's how we made this app installable.
Nice.
Now that's just part of what we can do. The next thing that you probably would be curious about is, well, how can we make this app then run offline? Well, the service worker can handle caching the app assets for offline use. There are various strategies for the caching behavior that you can use. In Blazor, we give you a service worker that implements a cache first strategy. So it'll always try to go to the cache first if it's there. Otherwise, it will go online. You could try to do other fancier things like go online if it looks like you have a network connection, and then you only use the cache when you're offline. Trying to detect whether you're offline or not can be pretty tricky in a browser. Like maybe it looks like you're online, but the network connection you have is flaky or slow or something like that. So a cache first strategy tends to be the simplest way to go. So that's what we set you up with. That only will handle the implementation of the app, like the app logic. For your data, you're going to need to handle caching the data yourself using browser features like local storage or IndexedDB, and then implement some sort of synchronization strategy once the app goes back online. Now, I'm not going to lie to you. Doing offline support in a PWA, there are some gotchas and some tricky things about it. We have some fairly extensive documentation in the Blazor docs about all of the concerns related to implementing offline that you can check out at aka.ms/Blazor offline considerations. But we get you most of the way there. Let me show you what we have so far. So with this app, well, this is a PWA. Does it work offline? Let's see. I'm going to bring up the browser dev tools. One thing to remember about PWAs is even though they look like a native app, they're really just a browser with a native app look and feel. So this really is still a browser hidden inside this native app shell. So I can bring up the browser dev tools and let's turn off the network. So now this app has no access to the network, and we can refresh it as if we're browsing to this app for the first time. And you can see doesn't work. So this app is not currently functioning offline. And that's because we're using that dev-only service worker. Like the service worker that we're using right now isn't actually doing any of the caching that we need to get offline to work. So to get offline to work, we have to publish this app and then use the published version. So I'm going to go ahead and publish the server project. I'm going to just publish it locally to my machine in a folder. And we'll go ahead and do that. And that should swap out the dev service worker with the one that will actually enable offline support. All right, just takes a second. And there it is. Okay, so I'm going to just pop this open. And we'll run the server, the published server executable. That's this guy right here. All right, so there's the back end. And now let's grab the URL for this. And we'll open this up in a browser. And yeah, let's do that. Okay. And you can see I'm going to install it again. I'm running on a different URL now because I published the application. So we have to install it again. Let's go ahead and do that. Okay, so now this is the published version of the app. Still works as before. We've got our fetch data page. We've got counter. Let's now again disable the network. So F12, bring up the browser dev tools, go to offline, and let's try and refresh. And it works. Boom. That's nice. So the app is now functional even without any network. And you can see that the service worker is handling all the requests for those app assets so that the app can still function. Now that said, it's not completely functional. If I go to the fetch data page, error occurred. You know, what happened there? Well, we can see that those fetch requests to the backend web API that provides the weather forecast data, those are failing. We're not able to connect to a backend web API because we have no network. And so this is the problem of handling offline data in this application. We've got the app installed locally, but when the network's gone, it doesn't have any access to its weather forecast data. So we would need a solution for that. But you can take care of things like that in a Blazor application. Let me hop over to a different app. Let me switch here to Card Checker. This is an app that we showed at the Microsoft Build Conference in May of 2020. And so I've actually got this app already running and installed as a PWA on my machine. So here's what it looks like. The idea with this app is it's like an app that an attendant at a car rental company would use, so that when you're returning your car, this is the app that they can use to check the mileage and check for any damage that you've done to the car. So it's got this nice little 3D rendering of the vehicle, and it's got notes on all the things that are dented or scratched on the vehicle. You can put in a mileage update, like let's say they did 11 miles, and we can just put what the gas tank is at 75%. And it has a lot of nice Blazor-like features. Like if we try to put in something silly for the mileage, it's like, no, that's not reasonable.
Not realistic.
Sticking in there. So all of the Blazor features are available in this application. But what I want to show is how this app can function offline, including with its data. So if I like, let's say I select this wheel, and I'm going to add a note, and I'm going to say, that the wheel might need to be replaced, and then we can add a photo. Yeah, that wheel looks like that could be a problem. So we save that. I've made all my changes, and then the attendant would click save. And because I'm connected to the so currently I can't sync, and that's because I have this app has a little login problem. My login credential is messed up. So let me log out and log back in really quick. Log out. Why are you doing that? Refresh. Log in. Okay. There we go. Let's try that again. So we'll go back to the app, and we've got our thing, and let's edit this guy. Needs new tire. We'll save that and save this. And okay, so that works. So last updated, and there's the timestamp. So I just had a little authentication issue there. And it's online, so it was able to persist the data to the backend store. But what happens when I go offline? So let me bring up the browser dev tools, and we'll switch from online to offline. And we'll go back to our car. Let's add another note. Like, let's say, this headlight is now out. Not working. Save that. And then if we try to click save now, which will try to go to the server, then we get that error again that could not sync. And we're getting all these failed fetch requests as it tries to go to the backend server to save that data. So it can't do that. But then when the attendants say, let's say they were out at the parking lot when this happened, so they didn't have good network coverage, but then they go back online, they can click this retry button, and the data is saved. So it's synchronized back to the server. So this app has offline support even for the data. Like you'll notice, even when I was offline, I could query for cars, I could look at all their details, their mileage, all that data was available. How was that possible when we couldn't see the weather forecast data for the previous app? Well, that's all done by persisting the data locally in the browser using, in this case, it's using IndexedDB. So if we go look in this data folder, this app has implemented this local vehicle store class. And this class is used for managing all the data for this application. And it's got this synchronized method where it's what is this? Like, so it will, in this case, it's using the HP client to actually try to go to the server. That will synchronize all the requests up down below. Where's the IndexedDB stuff? Like if I put async, yeah, here. So here, when you save data using this store, it will actually store the data first in a local store in IndexedDB, and then when you run the synchronized logic, which we were looking at up above, it will use a normal HTTP client to try and sync that data back to the server. So this is using JS interrupt, and I know with Blazor we try to tell you don't have to use JS interrupt, but there's a little JavaScript interrupt code needed here. Here's the JavaScript side of that code, and it's not too bad. Like here's the corresponding JavaScript put method, and it's using the IndexedDB APIs to store that locally. So this is the type of stuff that you have to do in order to handle offline data support in your PWA and then synchronizing it to the server.
So what I like about Blazor is if you don't like JavaScript, you can find someone who does, and they can hide it behind a C# library, and you can work with it just like any other native API because of the interop behind the scenes. So it's pretty nice extensibility story.
Yeah, in this case, Steve Sanderson wrote this app, and I think he went ahead and did his own IndexedDB JavaScript interrupt code. But if it were me, I would totally just go search on NuGet, find an IndexedDB library that's already written for Blazor, and just use that. Then I can just call these things as if they were C#. It's pretty nice. Now, the last thing to look at with PWAs, let me bring up my slides again. So that's offline execution. The last thing you might want to do is do push notifications, where you offline can send the user notifications about stuff that's happened related to your app. Like maybe you want to let them know that their pizza is ready, or it's been dispatched and delivered to their home. So push notifications are kind of interesting in the browser. in the case of Blazor, we don't really do much to set this up for you, but because Blazor WebAssembly apps are just normal web apps, you can pretty easily add the code to do push notifications to your application. And I'll show you how that's done. The way push notifications work is the first thing you need from the user is permission to send them a notification. And that comes in the form of a subscription. Like basically you ask for a subscription, you ask for permission from the user to subscribe them to these notifications. And if they say, yeah, that's fine. And you've probably seen this before, right? Like you have a website that pops up a little thing that says, hey, this website would like to send you notifications. Is that okay? And you probably almost always say no because they're annoying. But let's say it was an app that you really did want to have the notifications. If you said yes, then you would be giving the app a set of tokens that it can use to say the user has given me permission to send them notifications. You then typically send those tokens to your backend, like to the server side of your application. And then each browser has its own push service, and these are like cloud services that browsers use so that they can receive notifications from different applications. And so from your back end, when something happens that you want to notify the user about, you would then send a push request to the corresponding push service for that browser. And which push service you use, that's all in the subscription information that you got when you got the user to subscribe to your notifications. So you can figure all that out. So it's different push services per browser, but they all implement a standard interface, so you can talk to them all the same way. And then when that push request, if it's accepted, the push service will send the push event down to the browser, and you handle that in your service worker. Okay, so to set this all up, we're going to need to subscribe the user for notifications. We're going to need to trigger the push notification from our back end, and then handle the push event in our service worker so that the user can then see the notification. So let's see what that looks like for our last little bit here. I'm going to bring up a third app for this part of the demo. This is the Blazing Pizza app, which is part of our Blazor workshop. If you haven't done our Blazor workshop before, it's a lot of fun. Just go to aks.ms/blazor-workshop. And it's a GitHub repo with a full set of labs that will walk you through building this pizza store app. I've got that app just loaded here, and let's go ahead and get it up and running. There we go. So we can order some pizzas. This is all British pizza in honor of Steve. Steve wrote this app for the first time, and he's kind of the forefather of Blazor. He lives in the UK. All British flavored pizzas. This is a PWA, and I have the PWA version installed on my machine, so we can look at that version, which has the nice looking Chrome and stuff. All right, let's log in. And let's order some pizza. So let's order the Brit. We can select some toppings like duck sausage and
blazing hot peppers. That's my vote. Blazing hot peppers.
Blazing hot peppers, sure. And while we're at it, we might as well have it served on a silver platter because, why not? Nice. That's my kind of pizza. Okay, let's submit this order. All right. Now looks like I've already given this app permissions to allow notifications. So let me actually refresh this. I'm gonna ask. It needs to ask me for notifications because I want you to see that expression, that experience. So let's refresh this app. Okay, yeah. So depending on your notification settings, you might see something like this, where it's saying I've blocked notifications, but if you want to allow them, click here. And if you instead go into your browser settings, you can click on a thing to say it's okay for the browser to ask me for permission. So at this point, though, I can say, yeah, allow this site to give me notifications. That's going to allow Blazing Pizza to get that subscription. Let me fill out my...
One Microsoft away.
Yeah, let's send it to Microsoft. All my pizzas go to Microsoft. Okay, so then we have a little status page just telling me about the status of my order. Looks like it's preparing right now. But as soon as the pizza is ready to go, yeah, we get our little notification down here at the bottom. Okay, so that was a push notification. And we'll get another one once the driver finishes plowing through the streets of London, ignoring all, not only stop signs, but buildings and fields.
Wow, you even simulate the driver going out. That's awesome.
Yeah, well, sort of. Like we were too lazy to make him actually follow the road. So imagine
it's a straight line
or a bulldozer. Right. Okay. So how is this all working? How do we get that push notification to happen? So let's go look at the checkout page. So that's this page here. This is the one where we're putting in our delivery address. And you can see there's a line of code here for requesting a notification subscription. And again, we're using a little bit of JavaScript interop here. You know, we do have to sometimes delve into JavaScript for some features in Blazor. But this is invoking this request subscription call in this JavaScript file. Let's go find that. That's over here. Yeah, there's our pizza. Our pizza just got delivered. And notice that was offline, right? Like the app wasn't even running. So push notifications can talk to your service worker even when the app's not running. So here's the code where we're actually requesting the subscription from the user. And then if we get it back, then we get this, you know, set of tokens that we can use as proof that the user said it was okay to harass them with nagging notifications about stuff. So once we've got this subscription, then we send it to our backend server. So we have this little notifications controller where we send the notification subscription information to once we've got it from the user. And we're just storing that in the database. And then when we have an event that happens that we want to notify the user about, so here's our orders controller, again on the server. When the user's placed an order, and then after that, we start up a little process here to send them notifications about the status of their order. And here we're actually sending the 2 notifications that the order's been dispatched and then that the order was finally delivered. What does that code look like? Well, this code is actually now talking to that push service for the various browsers to tell the push service, please send a notification to this user's browser. Now, how do you talk to a push service? Well, you need something that knows how to speak to that standardized interface that push services implement. Blazor doesn't actually give you any first-class support for doing that, but fortunately, the community again has stepped up. Let's go into the NuGet packages for the My Server app, and you can see I'm using this web push package implemented by this person here, Corey Thompson. Thank you for implementing this and sharing it with the world. This is a library that knows how to talk to push services for browsers. So we're using that to then actually send the notification, the push request to the push service, which then results in the notification being sent to our service worker. And if we go back to the client project and look at our service worker for this app, you can see that it's registering an event listener for the push event and then actually firing the notification locally on the machine with the icon that we want to use and the message that we want to display. So that's how you can connect the dot with push notifications. Yeah. So that's the push notification. So that's Blazor PWAs. It's pretty easy to get started with. You can just check the checkbox and you'll have a Blazor WebAssembly app that is a PWA. It supports offline. It can be installed. We have wonderful docs on how to do this. Like, let me point you to one link real quick. If you go to the Blazor documentation and then just scroll a little bit down the TOC, you'll see this progressive web apps topic. And this has lots of great stuff that describes all the things I showed you and more for implementing your next PWA with Blazor. You can look at the card checker code that I showed today at aka.ms/Blazor card checker. And then, of course, the Blazing Pizza Workshop's available at aka.ms/Blazor workshop.
And there you have it. Blazor.net developers can build pretty much an application that'll run everywhere that there's a modern browser, which is phone, tablet, desktop. Check a box, run it offline, close the loop, good to go. .NET code runs everywhere. I love it. Thank you, Dan.
You're very welcome. Thank you.